Good morning, good afternoon, and good evening, everybody, and welcome to another episode of Loosely Coupled by Bridging the Gap. My name is Cuddles Kshmotsky, and I'll be your host, well, tonight for me, and this morning for our guest. And today we're going to do it a little bit differently, because normally we have a conversation, we share some screen shares, presentations, have a discussion, talk about a few books, etc. Today we're playing a game. And not just any game, because we're playing a game to learn test driven development. And to guide us through the learning process, we have Ted M. Young joining us at the stream. So, Ted, welcome to the stream.
Hey, nice to be here.
Amazing. So, Ted, tell us a bit before we jump into playing the game and learning TDD. Tell us what's your background? Why TDD? Why the game? What's going on?
So I've been a software developer at large companies that some people might have heard of: Google, eBay, Apple. I've been doing software development for, let's call it, some number of decades, and I've always one of the things I always tried to do is get feedback. So the earliest software I did was actually an application on Apple II Plus for my dad, who's doing stock market investing, and he wanted to do some technical analysis. And so I basically wrote and ported some software to do technical analysis. And I was always like, does this look right? Is this right? Tell me if this is right. How do you like this? Oh, that's not right. Oh, you want to implement this thing called point and figure charting? I don't know what that is. Let me look at it. Is this right? Does this look right? How do I check this? And so all throughout my career, there's always been this like, how do I know the thing I'm doing is right? And
Okay.
so, and obviously that was way before any kind of unit testing was known as a thing. And I got exposed to extreme programming, which I think still very much applies these days in terms of the practices. Back in the late 90s, when Martin Fowler was doing sort of a tour and talking about it. And honestly, I don't remember how I came across test-driven development. It must have been at one of the, so here I'm in the San Francisco Bay Area, there was a group called Bay XP. But I think I already was doing some of the ideas. Again, like do a small thing, get feedback. Am I on the right track?
Mm-hmm.
And so I tried it out, and I thought I understood it. Like anything learning, it's like, oh, I think I got it. And then you look back, a couple of years later, it's like, oh, I had no idea what I was doing. And then you look back again, it's like, oh, I still thought I was doing this, and so it's this constant learning about the nuances. And I think that's what makes things like test-driven development really difficult to adopt. Because if you look at the people who say they're doing it, a lot of them aren't really doing it, or they're doing it only at this surface level. And so in the late 90s, I was doing Java training. I had a company. We were doing some of the first Java training in the world. And I got tired of some of the travel. So that's when I joined companies like eBay and other companies, and really tried to incorporate better testing. And then after some political stuff at Apple, I got tired of that, and went back and became an independent coach and trainer, which is what I do now. Technical coach, sit with teams, help them. Basically, sort of my mantra is like, make it more enjoyable to work with your code. And what's more enjoyable than these constant dopamine hits of like, yes, it works, or yes, it fails as expected, which is also good news. And so that, doing a lot of training, that brought me to like, well, how do I teach them this process? Because it's not just a few steps. It's not 3 steps, red, green, or factor. There's actually a lot more that's going on underneath. How do I teach people that? And I was hanging out a lot with friends who were way bigger board game players than I am, and I thought, oh, that makes sense. Let me think about that. And so that's where we are today. And I've been working on the game for a while, and started playing it at various open space conferences. So Agile Open Northwest, one of the bigger ones here in the US, in the Pacific Northwest. Got some good feedback. Got some people who whose job it was to try and break the game, because one of the things that we'll talk about is like, how do you balance a game? It's really hard. And he broke it. So I modified some things and did some other things, and it's one of those, like, there was still rough edges, and I feel like 8 years later or 7 years later, it's like now I feel like it's done. Like, I tweaked the last thing, and now I feel like it's done. So that's where we are.
Right. Okay. And recently you had a bit of a tour with your game over Europe as well,
Yes,
right?
yes, yeah. So I've been, because all the great conferences are in Europe these days, or at least most of them.
Oh, that's nice.
And so I was at Como Camp and in Vienna, and basically ran the game. And the open space conferences are great because it's a perfect opportunity. People love board games anyway.
True.
And playing it, it's so much fun for me to watch people play and really get into it and have fun. And one of the things we'll talk about is like all the variations. And so over the years, I've collected, like, the way I currently sort of facilitate the game. Almost everything about that came from ideas that people had when they were playing it. Because people would say, "Oh, let's do this," and I'm like, "Go ahead, let's try it, see what happens." And it's so much fun to see, like, the things that people come up with. And over time, you see kind of like, okay, yes, you were half an hour into it, and you came up with this idea right on time. Good job. And so it's been really, so Como Camp and Socrates UK and some other conferences, and here in the US, there's a conference called Dev to Next coming up, and I've got actually a full session on that. Agile Testing Days in Potsdam, so back in Europe. I'm doing a workshop with the game, and so it's just, for me, it's so much fun to watch, and then people really. If they really get into it, it's fun for them too.
All right. So the game is supposed to teach us test-driven development. So for those completely unfamiliar, like me, with test-driven development, can you explain the principles? What is test-driven development, and why should we even care?
Yeah. So I'm going to share my screen here.
Sure. There you go.
So this is what typically people see or encounter or understand as test-driven development, right? Red, green, refactor, write a test, have it fail, make it pass, and then maybe refactor, although people fall down a lot on the refactor part. And in fact, so side notes, like when I teach test-driven development, out of a 2 full-day class, we spend 75% of the time not on testing, but on refactoring, because refactoring is an underrated skill, and lots of people have sort of basics on of it, but really digging into how do you refactor, because often the problem is, how do I test this? I can't. I need to refactor in order to be able to test. And that's why what I love about this diagram, to a certain extent, is like you can start anywhere, right? If you're in the green, right down here, you can say, okay, I need to refactor in order to write the next red test. And so you don't always start up here. Sometimes you start down here. But the way I think,
so by this alone, we can say that test-driven development is basically not only about testing. It's about really working on the code in a deeper, more meaningful way.
Exactly. And so the green gives you that safety where you can do refactoring. Yes, there are automated tools, and you can use other tools, but ultimately you're going to probably do some stuff manually or with some assistance, and you want those tests to be your safety net, to make sure that you haven't changed any behavior accidentally. Right? You want to sometimes change behavior on purpose. That's called adding features or fixing bugs. And those, that's where you start with the red. But if you're going to refactor and change the structure of code to make it easier to work with, you want to make sure you don't break any current existing behavior. And that's what the green tests are for. And so I actually split, I'm going to sort of divide this into 2 parts, right? So there is the part where we change behavior. That's the red-green cycle, right? You start out red. This is what I wanted to do. It's not currently doing it. Or this is what it's currently doing. I'd like it to stop doing that. Both are valid. Both are change in behavior.
Mm-hmm.
And the refactor part then is increase the changeability. Right.
Okay.
This is the part where it's like, now I want to make it easier to change or easier to do the next step. Some folks call it like, preparing the kitchens. Like you're about to do some cooking, it would be really inefficient to every time you need, I need some chopped peppers. You go to the fridge, you pull it out, you wash it off. Oh, the knife's dirty. Let me go wash the knife. Oh, the cutting board's dirty. Right. I mean, that would be like, it would take you forever to do. And then you're constantly going, oh no, now I need a tomato. And now I got to wash the tomato and I got to clean the knife and I got to clean like you want to prepare. And so it's the same idea with code. You want to prepare the code to be changed. And so sometimes that happens before, like I said, and sometimes that happens after. It's like, let's clean this things up. Let's make it better so that the next thing we do. But as I said, like, it's not really 3 steps. And so in my training, this is what it looks like, because I love hexagon, so everything is always hexagon. Not the prettiest diagram, but this was actually in a sense, the prototype for the game. So when we look at the game, we'll see like, oh, a lot of these things look familiar. And to me, it's amazing that the game holds up, even though it came from this thing, which was not at all game-like, but it's a sequence of these are the very specific tactical steps that I teach and actually do for test-driven development. And the first one is the most important, which is amazing how often we skip over it, is what should it do? Whatever this thing we're about to do, what should it do?
Yeah.
Define that in a way so you will know it does it. And I've done a lot of training where, before we get to TDD, I just, or it's a non-TDD class, and I say, okay, we're going to work on this thing. And, I walk around, look over people's shoulders, have them pairing up, and I'm looking and like, why are you writing all this code? What are you trying to do? And there's this stream of consciousness kind of way of coding that so many people do. I myself do it, but and you then like look and it's like, why did I write all that code? What was I trying to do? Because we're constantly thinking of new cases as we're writing it. And so one of the things that I love about TDD for me is it helps me focus. Like it really helps me like focus on what is the single tiny thing that I need to get done, and then I can go through the process.
Yeah, I think the key aspect here, because we're very used to the notion of requirements engineering, etc., but these not always precisely describe what the code is supposed to do. They describe it at a very high level, and that doesn't always translate to actual implementation, step by step, what is supposed to happen in implementation. Usually, no specification I have seen goes that deep, right? I mean, I can write that kind of spec, but usually nobody does.
Yeah.
It's up to the dev team to figure it out and add to the specification exactly what is the step-by-step execution to achieve that goal. And here I think that I see the key part of it when I'm looking at the diagram, the step 3, write the test for the code yet to be. So we're already writing a test even though we don't have any code to test.
Yes.
Where I think the majority of people that do not apply TDD, they probably write the code first, they then build the tests.
Yes,
or in like corporate environments, it's actually not even them testing the code, but the test unit testing the code, right? They write the tests. So they get requirements up front, so they do write the test, but that is completely disassociated from any development happening.
Yep. Yeah, and so even people who do TDD are like, don't always follow this precisely, but that's exactly right. Like, because if we think about like why we're writing code, what's the point? The point is to provide some piece of functionality, however you want to describe it. It's for it to do something. Yet, instead of saying, here's what it should do and here's how I know it will do it, or I know it did it when I'm done, we start just writing the code. And then we write the test after, and 2 things happen. when you do that. One is this confirmation bias problem. You tend to write tests that, like, imagine you wrote a whole bunch of code, you spent a whole bunch of time on it, and then you write tests to purposely try and break it. That is super hard because your mind is like, no, I don't want to, and you find out like you have to throw away all the code. Like, no, I'm not going to do that.
That's my baby.
Exactly, right? So sunk cost fallacy, all these things, loss aversion, are make it really hard to, in a sense, be adversarial about your code. And so we tend not to do it. The other problem is we may find, oh, I need to observe what the change is in this piece of information, and I can't because I didn't write the code that way. And so now it's like, do I have to got to refactor the code? And now I don't have any tests for it. So how do I refactor safely? Maybe I'll just write it, and this is why people tend towards like these end-to-end tests, is because yes, they're much easier. There's a defined API endpoint, and then there's maybe a database that you can access, or just round trip on an API, because those endpoints have to exist. But everything inside of that code behind that, you don't have to have any entry points that are testable. And so if you write your tests last, they might not be easily testable. Mm-hmm. But if up front you write the test first, then by definition, the code is testable. And that, if nothing else, is of huge benefit.
That's true. That's already, if I'm looking at this, the granularity, if you write the test first and really look at what I can test straight up, it's like this already points towards the direction of actually building modularity in code.
Yes, exactly.
So that you can divide the code and just conquer it in terms of small snippets that you can actually test, and then connect it all together to make a whatever you're building, right?
Yes.
I now I realize that I actually went through the notion of really heavy refactoring and testing for all the automation I'm writing. For also creation of those of our live stream here. It's like over the last, just after TDD Europe, I spent like 1.5 weeks refactoring all automation code base, like really splitting it into modules, because I wanted to apply something new, and I couldn't because it was all so encapsulated that I had to like refactor heavily to be able to do that. And I was literally testing as I went, like, okay, let's build the test function so that I can test the output of it without actually, I don't know, putting that much in it.
And that's what happens. So you still want to have a good sense of design. So this is also what makes TDD hard, is because you have to know how to refactor, but you also have to know how to refactor in a certain direction. Like one of the big things that I talk about, in fact, my video from JCon Europe just came up on testable architecture, is I basically say you need to separate your code into two pieces: the code that does sort of calculations and logic, and the code that integrates with the rest of the world, what I call IO. And that's it. Like, yes, you can go clean or hexagonal or imperative, functional core imperative shell or A-frame. Like, there's a whole bunch of variations, but fundamentally they're all about, where am I crossing the boundary to talk to the outside world? That requires a different way of writing tests. And where am I sort of in my domain, where it's all about rules and logic and calculations? That is a great, easy way to test, but you still have to know where those seams are, and how to handle that, and how to refactor your way towards that. Yeah, there you go.
Yep.
And it's funny because, like, 3 minutes into my talk, it's like, I'm done. I've given you the principle, and the rest is just examples. But it's really hard to apply that in most code bases, because they're so intertwined with, oh, let me go fetch something here, and then I'll do some calculations, then I'll go write something there, and then I'll fetch something. And it's like, now you end up having to test everything, because it's, like you said, it's like, it's not modular. It's all this, little ball of mud instead of perhaps a big one. And so writing the test first really forces you. And it's that, again, this idea of feedback. You find this out before you wrote a bunch of code, right? You find this out when you try to write the test. Oh, I can't access this shipping charge that I need to check that it's right. All right, let me
Yeah.
refactor my domain model and move things apart so that I can now finally test it. Uh, and that's, and so again, what makes TDD hard is it's not just write a test, watch it fail, and then make it pass. It's all of the thinking and design work, right? In fact, some people say it shouldn't be, test-driven development. It's basically design driven by tests, right? So like tests happen to be the thing you do, but it's really all about the design and how to design things. And my tendency is, sometimes you end up with stuff that's maybe too granular and
Hmm.
too scattered. But in my experience, what I see in most organizations is everything is in one file, and it's really hard to test because I can't even instantiate the thing to call a method on it.
Yeah. So I'm looking at this from this perspective that now skill set wise, and I'm thinking to myself, well, okay, if you're just literally what people tend to call a code monkey, so you're basically typing in code, you will not be able to do this
No.
because this requires actual knowledge of the architecture of code and how to build code in a modular way. What does that even mean? How to organize your code so that it makes sense, how to divide it, partition it, either technically or domain wise.
Right.
All these skills that are actually very much software engineering skills
Yeah.
that are far away just from writing code.
Yeah. Yeah. I kind of liken it to like, it's very easy to build a house of cards that's one card high, right? I can do that.
Yeah.
I can, build a really broad, house of cards that doesn't stack anything on top. And that's relatively straightforward. Maybe I can build one level up. Once you want to build like a tower, forget it. Unless you have that solid foundation, it's going to fall apart very quickly. So you can do TDD without, in a sense, the refactor design sense and skill for a while. But you're going to get to a point where it's like, I just can't do this anymore. Oh, test-driven development stinks. And it's like,
Yeah.
yeah, no, you got sort of part of it. You need to learn more about design. Although one of the things that TDD can provide is that quick feedback of like, I keep running into this same thing. Maybe there's a pattern here. Maybe I can do this other thing that seemed to work before. And so with some basically a lot of sort of trial and error, which is what we call experience, right? Making
Hmm.
mistakes, you can learn about it. Although it's a lot more efficient to have someone guide you. And this is why I talk about, why I'm a learning experience designer, why I call myself that, is because learning is not about watching somebody else do it or reading about it. It's about, and it's not even like, it's not even about trial and error. It's like, you need to experience it, right? You can't learn, how to play guitar as much as you might want to by watching YouTube videos. Ultimately, you
That's
have
true.
to fingers on strings, and you have to do that. And it's the same thing with learning anything. You have to. I always have this phrase, and I forget where I stole it from. It's like, I can show you, but I can't experience it for you. You have to do the work.
That's
And
very
and
fair.
and so, my goal as sort of a trainer coach is to set up the situations that will maximize that learning, and say, follow these things and give you feedback, that you can then, but really, I want to put you in positions where you're going to feel a little bit of pain, so you can feel like what it's like to be in that, and then how to get yourself out of it.
That's fair. I think without if we go with this to the position of ego, like this is my baby, this is my code base, I catered to it. You're not going to grow from that position
Yeah.
into anything substantial. You're going to get locked into that and basically stay there until you break.
Yeah.
And that's troublesome because looking at the industry today, code that we write is the most disposable thing ever.
Yeah.
Literally.
Yeah.
I really have not seen code that lasted more than a few years. Even if it lasted, it was heavily modified over the years.
Right.
To whatever purpose and extent. But basically, yeah, it's there. It works. Okay, fantastic. Now we have we drifted away into a different direction. Now we need to modify it to facilitate for something slightly different.
Mm-hmm.
Just looking at my code base for automation, the number of times I had to edit it and change it because I figured, oh, I can automate this piece of work that I'm doing manually,
Mm-hmm.
and maybe I actually should, and then just crack it right over a weekend or over a few evenings. It's like the code that I originally had for all the automations that I do on Google Workspace. I mean, parts of it are still there, but really only parts of it. That code base grew from like 50 lines of code because that was the extent of the script I wrote initially. Now it's a thing well over 1,500 lines
Mm-hmm.
to facilitate for what I'm doing, spread over multiple code bases because now I had to this is for this is for this. So partitioning had to happen.
Yes.
And this is if you just jam it into one file, you're not gonna get out of it to learn it in that sense.
Yeah, and I've worked in a lot of code bases where people jam a lot of stuff in, and they just keep jamming it in. I recall this. It's stuck in my head for a long time. I was looking at this code in Google when I was working at Google, and there was like 49 if-else statements in one big block, and I'm like, oh, I can see what's going on here, and my job was basically to add the 50th. And I look back and like, oh, I shouldn't have done that. I should have basically spent the time to refactor it so that the next person who came along didn't have the same reaction and say, oh, now I got to add the 54, and that's what happens, right? It's, it starts out as 2 or 3, maybe 4, and then people tend towards the path of least resistance, which is I'm just going to add one more, which makes testing really, really, automated testing really difficult for that. And I look back and I'm like, oh, I should have spent the time to refactor it because then it would have been a lot easier. But a lot of times, like, I think I went into that code, added the thing, and I never touched the code again, which happens, right? And that's why we don't easily change our behavior in those situations because we haven't learned anything, right? Learning is basically you hit up against some edge, you find out that there was a better way. But this is why if you only stick around a company for a year, 18 months, you never see the consequences, good or bad, of the things and decisions that you made. And that makes it really hard to get experience because, again, like, we make mistakes. And the question is, what do you do with those? Do you learn from them? Or do you just not ever see the consequences, and then you just keep doing whatever feels easy,
and you just move on elsewhere, right?
You just move on elsewhere.
I remember some feedback loops of me learning as a young professional back in the day that took me, I believe one of them took me like 4 years to close, because I was like, I built something as a junior, then I progressed, then I was hired by the client as an actual architect later on. And then at a certain point, I'm working on this project, preparing specs for the dev team to actually build integrations. And I'm like, looking at the code, because I was very hands-on architect there. It's like, who the hell fucked this up this badly? Then I go into SVN. Yes, SVN, because that was still Subversion.
Yeah.
And I was like, where is this file? Let's see oh.
Yep.
I did. 4 years ago. Makes sense. Okay, now I understand why that was a bad thing to do, and now I understand how it constrains my further extension of the code. And it's like, yeah, let's fix this.
Yeah, and sometimes, so I worked at a company called Guidewire Software that creates insurance for some of the largest property and casualty insurance companies in the world. And what Guidewire is selling, at least back then, this is sort of before the cloud became big, is basically sort of 80% of the software. So I was working on the billing system, and the feedback cycle was super long because we basically released something, but customers would then probably not upgrade for a little while, and then it would take about a year before they upgraded. So you do something and you wouldn't find out whether it was the right decision or not until almost 2 years later. And I remember we made a decision, okay, we're going to do something here that will make this easier for people to configure. And it turned out that was a waste. that actually there was this other place that they needed it, and we didn't do that. And so it's like, so we wasted time here that they didn't need, and then over here where they did need it, we didn't do it, and we didn't find that out for 2 years. And so for me, that really confirmed this idea of YAGNI, which is you ain't going to need it. It's like, unless you have faster feedback cycles where you can figure out if you need that, it's a balance. Most software probably doesn't fall under that sort of very long time cycle, although it baffles me that people don't look at the outcomes, testing aside, of the functionality that they've added to the system. Did it help users? And I don't necessarily blame developers, because they're almost forced to be distanced from the actual customers, users, and you have the problem of the people who buy the software and the people who use it, especially in larger corporations. But like, you do stuff and it's like, did this work? Did this help anybody? Is this better? And a lot of times as developers, we don't ask those questions. We just move on. We assume somebody else is taking care of it. But I think that distance means we don't learn. And that's really kind of what the business is all about.
And if you're doing a domain system and you're actually building some front end, etc., then you actually have some idea over whether or not it's helping. But if you're deep somewhere entrenched in the backend system or in middleware, I mean, the feedback loop for middleware in large corporate environments, that can go years. If you don't have the right software development lifecycle in place to be able to go through and actually validate where the measurable outcomes are actually defined, that's absurdly, ridiculously difficult to figure out whether your changes in code are of any value.
Right.
And then of course in the engineer's head it goes like, okay, we're in a constant battle between wet, dry, and aha, right? It's like, should I not repeat myself, or should I write everything twice, or should I just avoid hasty abstractions and like really spend time on that refactoring and redesigning it so that it makes actual sense? It's like, where should I be here?
Yeah.
If you go microservices, then you'll go like, write everything twice. If you go more in the monolithic direction, don't repeat yourself. You already have that, right?
Yeah,
people that go crazy about that, right?
Yeah, and dry is misunderstood. It's like find the right abstraction. It's not about the surface level. It's like, am I duplicating some source of truth, some fundamental rule or other thing, and are these really the same things? And it can be hard. And sort of
because it's abstract.
Yeah, I mean, it's like, is it abstract? Is there an abstraction here? What does that mean? Can we name it? And a lot of times trying to come up with that name reveals, oh, maybe there isn't one. Because if sometimes it's like, they'll say something with the word and in between. It's like, if there's a word and, then that sounds like two things.
If there's like handler management, it's like, that's a code smell.
I mean,
you probably don't understand, but it was
some, and there's also a trade-off in terms of some of that naming of like, you don't want to go too far from what people readily understand and recognize, because we're pattern matching machines to a certain extent. But
come on, Ted.
Yeah. Oh yeah,
Ted,
like
you definitely have in your code base somewhere a package called utilities. Everybody does.
You might, and that's okay as long as there's no domain stuff in there. Like if there's string utilities, that's totally fine. Trim them stuff and split stuff, that's totally fine. But if you've got like shipping charge calculators as utility, like, well, what are you doing here? Like,
that's the main logic. Basically. But people like I believe that in my conversation somewhere with Mark Richards, we were discussing, sparring on naming certain things in integration architecture, because there are some things that remained unnamed for the last 20 years. It was like, how to call it that it makes actual sense. It's like understandable yet distinct enough. It's like when Mark was like, naming things is the most difficult aspect of our job.
Yep.
properly name it so that it actually makes sense, that it's not misunderstood from the get-go. It's really difficult, and that comes with refactoring, that comes with thinking about domains, thinking about functionality. All of this is like, okay, how do we properly define this and give it a name that is actually understandable within the jargon that we're using, whatever that jargon may be,
Right.
anywhere.
Yeah. I mean, that's the fundamental aspect of like, ubiquitous language and domain-driven design, a common language. Like, that's really hard. And it should be hard because we're talking about not some code technical thing. We're talking about how do we communicate about this thing? And what do we call this thing? What do you call this thing? What is it called in this context? And sometimes and what is so I remember, so on the billing system I was working on, there was bi-monthly. I'm like, is that every other month or is that twice a month? And like, even that word, like, and people get confused about that because sometimes it can mean both things. It's like, oh no,
Yeah,
bi-monthly is every other month, semi-monthly is twice a month, because we have the different payment plans. And it's like, oh, okay. Let's make sure we define that really well, because that's going to be easily confused.
yeah,
And to me, what it comes back to is like, I remember, learning vocabulary when I was a kid. It's like, use it in a sentence. It's like, let's use this in a sentence. Let's describe it. Let's provide examples, right? And examples are such a both a pet peeve of mine and like something that I always try to do as a learning experience designer. One of the things that we don't do enough of, and I see this in documentation, I see this in talks, I see this in every place, is not enough examples. And examples, in fact, are one of the things that TDD needs. You need an example because, in fact, that red test is an example. When I do this and this, and I expect this, that's an example, because it's not just hand waving. It's gotta execute. And we learn from examples, and we need these examples. And so it's like, if we come up with some phrase that we think is appropriate, let's use it in a couple places. Does it fit in all those places? And so, like, if you're trying to explain bi-monthly, well, the best way to disambiguate it is like, well, it means, January, March, May, right? Oh, okay, I see, right? But otherwise, if you try to just use other words to explain it rather than just an example, it's still open to confusion.
Or just refactor the name to actually be
or maybe every other month. Yes. Right. I mean, sometimes like, you want, sometimes, and so Arlo Belshi has this thing where it's sort of the 7 stages of naming things. And like, one of them is just honest. Like, it may not be the shortest, it may not be some nice abstraction, but it's basically like every other month. Okay. Like, that's super obvious. Maybe bi-monthly is the jargon term, but if people get confused, maybe every other month is fine. Maybe every other month in odd years is the name, and that's okay. At least it is honest. At least it is saying what it does. It might be a bit wordy, but that's better than something that is easily confused. Yeah.
Yeah, and then from that we can derive proper levels of abstraction.
Yeah.
With abstractions, I find the biggest problem being that people confuse levels of abstraction.
Mm-hmm.
They're here, they're talking about this, and the naming is completely not matching the level we're actually talking about, and it becomes a whole nightmare. And this translates from code to architecture.
Yeah.
People don't understand on what level of abstraction there are in architecture as well. Sometimes they're on a level higher, but they still try to apply principles that are for a lower level, and that will not work because, well, you're somewhere else.
Yeah.
Obviously.
Yeah.
Right. These are difficult things, and you're right. In that sense, you need to like really go and use your brain and figure it out. If you're just gonna want to get things done and out of your way, then that learning is not going to happen.
And it also means, like we said before, it's like learning is making mistakes. It means you're not going to get it right the first time, and this goes back to sort of the loss aversion. We don't, it's my baby, I don't want to throw it out. It's like, maybe you find a better term or a better way to write it, and not be egoless programming, right? That's that whole thing of like, I found a better way, so let me do it. I found a better name, let's do that. We thought it was this name, but actually this is better. And it's not that, some people say, oh, I made a mistake. It's like, you did the best with the information you had. So Norm Kurth has this thing called the prime directive, which I would always use as part of retrospectives, right? Basically, we did the best we could with the information we had available at the time, right? We had the information as much as we could. We had to make a decision. We made a decision. We did the best we could. That's not a mistake. You did the best you could. And there's no way it could have been better. Now, if it could have been better, like maybe we didn't have all the information that we could have had, or we didn't spend enough time, or we didn't actually make an active decision. Like I see that all the time. It's like, oh, I'm going to use Spring Boot. Let me use JPA. It's like, why? Are you sure you need to use that? It has some costs to it. Do you know what those costs are? Have you weighed those costs with the benefits? That's an active decision. You laid it out rather than just like, we'll use that. It's like, so that was a mistake because you could have collected a little. You didn't have to spend 2 weeks on it. You could spend an hour, and so there's a difference. It's like, did we do the best we could with the information we had available at the time? And then that's fine. And then stuff changes. You learn new things. You find out something maybe you didn't know about, and then you can change your mind. You can change the way you do things. And for me, as a TDD sort of supposedly expert. I changed the way I did TDD, I don't know, doesn't feel like that long ago, but maybe it's 10, 15 years. Yeah, the project retrospectives. And he calls that the prime directive. And every time I would run a retrospective, we would all read that, right? We truly did the best we could, because it's not about, oh, you should have known that. It's like, we didn't know that. Or should I have known that? How would I have known that? What went wrong? What was failure to communicate between two people or something like that? Because that's what the learning is about. And that's basically sort of getting it out of like, oh, it's your fault. And it's just like, it happens. Let's see if there's some way we can make it better the next time. So that doesn't happen. Or it happens. How can we make it easier to change, right? Instead of, there's this tendency, and you probably experience this as well. There's this tendency to like put up more quality gates, put up more road bumps, to slow you down because, oh, we made this mistake. Let's make sure this mistake never happens again by putting in this rule. Well, now you've slowed things down because that rule, now gets in the way. And then you keep piling on rules, just like at least the legal system here in the US, you keep piling on laws. You never take any away. And so you end up with like, why is this so bureaucratic? Why does this take so long? Because these rules have built up over time to prevent problems that maybe happened once and that no longer serve their purpose. And when do you reevaluate those?
And because everything needs to happen in context, especially in software design, that basically if we apply a generic rule because something happened, that rule will be getting in the way all the time because it probably happened once and never again. And now we need to deal with that rule because somebody figured it's a good idea. It's like I don't know, from my perspective of working on various frameworks in terms of project management, it's like story points. Like somebody figured it's a good idea, then the original author even said that was a terrible idea. Do not do that. But no, everybody is now doing story points. Nobody knows what a story point is, but we're doing story points. And then people confuse it for actual time. Nobody understands that the whole idea, for good or bad, right? Again, it was like Ron Jeffries says, like, we thought it was a good idea, we did it, it helped, because the purpose was to explicitly get away from trying to estimate things in time, to try and get a sense of effort and how complex it is. And I think it can still serve some purpose if you just say, and this is where people said, oh, then let's switch away from numbers to what, t-shirt sizes, small, medium, large, which is fine if you understand the original intent, which is this small and that's what we want, or is this large and needs to be split up? But once it got turned into basically measurements, it was like, what are we doing here? Like, that was not the original intent. And this is where Agile is today, right? The intent was great and it works well if you understand what the intent is. Like this idea of a sprint being 2 weeks. Like, no, actually it was originally a month. Like, why was it a month? Because that's the way our systems work. But it wasn't defined. It wasn't even defined as a month. It's like the idea of having these regular things is like,
what is the overhead of these time periods? What's the purpose of it? And so much software development is just copying what other people do, right? Cargo culting. Oh, they do that. That works for them. Let us do it, right? And
on all levels, literally.
And then it's like you basically only have the surface implementation without understanding the reason why. Why do we do that? So when I joined Guidewire, they were doing kind of monthly sprints, and it's like, why are we doing this every month? It's like, that's just, it's like, how about we try a week? Let's see what happens. And so this idea of experimenting, to me, is a fundamental principle of how to improve, right? You run experiments and you learn something. And then if it turns out that thing worked well, then maybe continue doing it. If it didn't work, examine why it didn't, maybe run a different experiment. And so we ran an experiment. Oh, well, there's a lot of overhead we had this super complex merge process that would literally take a day and a half of just someone doing merges. And it's like, okay, if we're doing it every week, that's like 1 day out of 5. So that's 20% of our time just merging. That's a lot of overhead. Maybe a week is too much, is too small. Let's go with 2 weeks. 2 weeks felt fine. We were making progress. But if 2 years later you're still doing 2 weeks, it means you're not paying attention and you're not saying, well, again, what is our overhead? Why, you want to have some cadence because you want to do retrospectives, you want to do demos, you want to do all these things. But maybe we don't need fixed periods. So we actually switched away from that completely. And we learned something there. It's like, oh, we forgot that we need some of these cadence for these things that are actually important to do on a regular basis. So let's bring those back in. And we went, completely to because we were and I was really pushing this in the company to constantly experiment and try things out, because the only way you get better is by trying things out.
Yeah.
If you're just gonna do the same thing you did 30 years ago, well, then the companies that are experimenting are gonna pass you.
Absolutely. All right, but there we drifted so far. But it's still very on topic, because this is all relevant, because it's not only about testing. So it's about that, engineering way of thinking, and all these examples really go into deep into that.
Yeah.
But going back to the test-driven development, should we start learning some?
Yeah.
And again, I don't know much, so tabula rasa. I did testing, but basically, why not? Maybe I'll actually start actively applying TDD. So, screen share again?
Yeah, screen share.
All right, there we go.
So I'm going to talk about this in 2 ways. One is sort of the, what do I do when I'm doing TDD, and also then how this became part of the game, because I think this was really difficult for me to figure out, how do I translate this to the game? But the idea of what should it do, right? And so we talked a bunch about that. And then how do you know it does it? So basically, how will you know, right? You know what it should do, right? So I always use the example of now we have to charge tax on shipping, because that's the law changed. And so now we have to charge tax on shipping for some bizarre reason. So I expect now when we calculate tax, that it's not going to be, $25, it's going to be $35. Okay, so now we know what it should do. How do we know it does it? How do I get the tax off of this cart that I'm going to evaluate? Okay, there's a total price method. Well, that's not what I want. I want just the tax part. Oh, looks like the tax isn't easily exposed. Let me go do some refactor. Okay, now I can access the tax. So how will I know it did it? When I call get the tax amount, that it will return this amount, right? So this is this preparing for writing that test is like, I know I can access the information I need. You have not written any code. You've looked around at code probably, but this is the hardest part, because this requires thinking. This requires, what do I need it to do going back to the example, right? I need at least one, but more likely you need several, if not half a dozen examples. well, what happens if it's this kind of shipping versus this kind of shipping? What if it's shipping to this location and not this location? Like, what are the boundaries of this thing? And all that happens here. And then you finally figure out, okay, what is the one little piece I'm going to work on? Okay, shipping from here to here with this amount should cost this. And so then finally you can go on to basically the next part. But I want to stick with this for a second, because in the game, which pretty much, right, if you look at the actual board layout, right, this is, and we'll play with it live. This is the board layout, and if you look at this, right, what should it do? How do you know it did it? Actually changed this tile. Now it's how will you know it did it? I was trying to think, like, how do I translate this into a board game? How do I, like, I want you to have, there's this idea of sort of spending time or spending effort that initially was just this part of the game. It's like, okay, well, a turn in the game is playing or discarding 3 cards. Right? You get a hand of cards, you get a hand of 5, and so your turn is up, and the next person goes when you played 3 or 5, discarded or played 3 cards. It's like, oh, well, let's use up some of that turn to do that. So you have to discard a card, and so it's a little weird, but it's like all you have to do to get from this tile to the second tile is just discard a card. Except it's not that easy, because you have to think about, well, what cards am I okay discarding? I might need this card later, but I have to discard a card, and so now you're forced to think. And so I was very happy once I figured out sort of that mechanic. I was like, oh, just discard a card, because they have to make a decision, and it's not an easy decision. And so this idea of, in the game, playing cards or discarding cards as being work, as being effort, it sort of underpins the whole game. And that didn't become obvious to me again until I play tested a lot, and people, and I had this guy Arthur at JCon. So JCon Europe, there was Bruno Souza set up this mentoring hub, basically sort of alongside the scheduled talks. There was an open area where there were coaches and other people who would talk about career and other things. And someone suggested, hey, Ted, submit your game and have people. It's like, but it's the mentorship hub. It's like, no, do it. So I did it. Turned out there was this guy, Arthur, who had bought the print and play version of my game. So he had to print it out and cut it out. And like, there's 90 cards.
Yeah.
And he had submitted also to play the game. And so it was like, I didn't know about it. And then I was basically watching him facilitate my game. And he was relatively new to it. And I got some great ideas from him. And so he sort of had this idea of like, your turn is up, your day is over, it's time to go to sleep and recharge for the next day. And I sort of love that analogy of you're using up energy to do work. And it really does fit the game really well. So this part required some thinking. And then this part was one of those, like, okay, how do I turn this into a game? Like, so one of the things that is sort of fundamental is, besides sort of this idea of work, is this idea of prediction. And so like I said before, some time ago, I said, when a test fails as it's supposed to, that's a good thing. Even though your test is red isn't always bad. And so I've come to call that an olive, right? So both the color, it's green, but there's a tint of red in it, but also the what you might find in your drink or in a appetizer. It's green, but there's a little red pimento. There's a little red part, right?
Yeah,
because
bell pepper.
Yeah, because it's failing, but it's failing for the right reason. And that is so important. And so I basically made this idea of prediction a core part of the game, where, because this is what I do. If you watch my stream, I actually go through my transcripts and look for every time I do this, and at least 3, 4, sometimes 5 times a stream over a 3-hour period, I have a test that fails in a way that I did not expect. And that's important. That is something that we want to pay attention to. And so this idea of prediction primes us for looking out for these things. And so it's kind of easy. It's like, okay, I wrote some test code. The functionality doesn't exist yet. And so, of course, it's going to fail to compile. But wait, there's already a method that does this? I didn't see that. I didn't think it did that. Now I'm confused, which is good, right? Confusion means you are aware of there's something missing in your mental model that you need to repair. So you go figure out, oh, this method's already there. Oh, it doesn't do what I thought it did. And then you go do some thinking and some work to straighten yourself out. Maybe you even have to go back and find out, this looks like it's somewhat implemented. What's going on, right? And then you finally come back and say, okay, I've written my test, fails to compile as expected, and now I need to write the least amount of code to get it to compile. And this is important because one of the things that, we talked about earlier, the stream of conscious way of writing code, we write more code than we need. Maybe we need it, but not yet. Maybe I'll need it next week, next month, or maybe I'll need it in an hour, but I don't need it right now. And so the more code you write, the more it gets in the way of the things you might want to do. And so this idea of write the least amount of code to get it to compile is really important. And if it's a language that doesn't have compilation, then at runtime it's going to fail. So whatever is the minimum amount. But it's not supposed to work yet. You're just supposed to take these really tiny, safe, validatable steps, right? It didn't compile, and now it compiles, right? And these small steps sometimes feel tedious. But to me, I like them because it's very much like I'd much rather, walk up, well done stairs rather than have to take huge steps and then fall down and break my ankle. So small steps are great. It also means you're interruptible if need be. All sorts of good reasons.
That's pretty much sounds like the way I build code for workspace automation. It's basically I write the part, test it, does it work what I wanted it to do? If not, then I write some more code, etc. And I think that the aspect of me being an absolutely lazy neurotypical engineer that wants to automate stuff and just be done with it helps with that, because I don't want to write a code if I don't have to.
Yeah.
And that's kind of makes it easier to grasp.
Yeah. But this is even before the functionality exists. This is just, can I get it to compile? Because if it fails to compile, at least like in a language like Java, I can't even tell if the test is failing yet, right? I need to get to red, right? And that's why this here is actually kind of not red. It's kind of this amber, orange, yellow color. Once I get to here, now I predict. Okay, the code can actually compile. I can actually run the test. Before I run it, I predict precisely how it's going to fail. Okay, the shipping charge is this. The tax should return 0 because there is no tax yet on shipping charges. That's what I'm going to change. And if it returns 10, you're like, what the heck is going on? It was supposed to return 0. Or even worse, or sometimes better, but also happens like, why did it throw an exception? Why is there an error? What am I missing? Right? And so every time you do a prediction, it's basically saying, based on the mental model in my head of how the code is working, I predict it's going to do this. And if it does, then your mental model matches as far as you know. If it doesn't, you need to now take a step back and do some work. Look at the code, look at your test. Half the time for me, probably 3/4 of the time for me, it's I wrote the test wrong. My setup was incorrect. I had some wrong values in there. And so, because sometimes people say with TDDs, like, well, how do you know your tests are correct? Like, well, this is one way, right? If the prediction fails, you might have set up your test wrong. Yeah. Although sometimes it's you don't have an understanding of the code. Either way, you have to do some work. And in the game, this was actually a core piece that took me years and years to fix, and I finally fixed it. And it was like, oh, finally. Now I had to rewrite some of the rules to adjust for that. But we learned. And so when you run the test and it fails in the predicted way, notice that this is kind of that olive color. It's not red. Yes, it's a failing test, but it's failing the way you said it was going to. And that's what is key. And it just amazes me how often it happens that it doesn't fail in the way you expected.
And I would say that this is a very important notion here, that we also have to design tests to fail on purpose,
Yes.
because they also validate some things
Yes.
that the code doesn't output this.
Right.
That's perfect. That's perfectly right. It's the same notion, for example, with understanding of coupling.
Yeah.
There are types of coupling that we actually want to have in our software.
Coupling's not bad.
It's not bad. It's not that we need to all suddenly remove all coupling, as much coupling as possible. No, because actually coupling at a certain level in code is cohesion.
Yes.
And we want the systems to be cohesive, so we want certain types of coupling to exist, because otherwise this would be just humongous cognitive load to understand the code base. But if we're doing system to system, we really don't want that much coupling there, but we still want to have semantic coupling at least, so that they understand what they're transmitting between one another, etc. So this is exactly the same balance in tests, where you want to have tests that prove that the code works, but you also want to have tests that prove that it doesn't output what you would predict that it shouldn't output.
Right. And there's two other things. One is you're not, when you're doing TDD, you're writing it one test at a time, but you're always running all the tests, or at least some large subset. And this is where getting that separation of concerns around tests set up correctly, so that, like, if I have to wait more than 2 to 3 seconds for the test to run, I'm unhappy, and I'm going to go look at why is it taking so long. Sometimes you can't avoid it. Maybe you're working in a language where the compilation is slow, or maybe you're working in something where that cycle is slow. But for me, if I'm working in my preferred environment and it takes more than 2 to 3 seconds, I'm like, I got to fix this, because I'm running it multiple times, possibly per minute. Like, I might be running it several times a minute, and if it takes 10 seconds, that's not good. The other thing is that when the test fails, right? So we're doing really two things. We're seeing fails in the right way, but also, and this is because you mentioned, seeing the test fail. If you never see your test fail, how do you know it's going to fail? How many tests have we seen where it's like, no matter what you do, it continues to pass? And I'm like, okay, it's clearly not testing anything. The other is, if it does fail, does it give you useful information? If it just says expected true was false, that's not really helpful, because now you got to go look at the test and figure out what was it trying to do, what was false, what was true, and maybe the name of the test can help you. But that's an excellent opportunity to improve the assertions output and give some more detail about what was expected, why did it go wrong, or why did it not, what was expected, and what was it, and why that might matter.
But you see, this is a actual human behavior that we observe now also with coding agents. We do not put emphasis on comprehension of code very often. There are already tests on comprehension of code with people not using coding assistants, with using coding assistants, or completely delegating to LLMs. But if we look at testing in this aspect, then we already saw that LLMs tend to build tests that always pass, no matter what, to the code bases that they're working on. So if you delegate your code and tests to the same agent, well, you're screwed, because those tests will prove absolutely nothing. Because there's no comprehension of what is actually happening.
There's no
LLM has no idea.
Yeah, there's no mental model, right? And so to me, a lot of the TDD is updating and confirming your mental model, and preparing for it. You already now have a mental model of what the code should do, because you just wrote a test for what it should do. And so you have actually in your head two mental models. One of or maybe it's a nice expansive mental model of, like, what does it do now and what should it do? But you have a model in your head, and you're trying to match it, and every time you see something not right, like it doesn't fail in the predicted way or it passes for some strange reason, these are all like, oh, there's something wrong with my mental model. There's something I don't understand in the code base. But yeah, LLMs don't have a mental model because there's no mental there, and they don't have a model of anything. And some folks who do great work in terms of creating skills and so on, and have done some stuff where they try to replicate this process, and I'm like, that's really interesting, but can we think about what the purpose is here? Like, let's say I could get an LLM to exactly follow this process. What is the point? It's not building a mental model that gets updated, right? It's not that kind of machine learning, right? It's not like this. It's basically like, it's just doing stuff, but it's not like it's building and changing and updating a mental model. And so to me, it seems kind of pointless to replicate this, because TDD here is not about failing and passing. It's about that mental model, keeping it understandable and comprehensible.
Because in the end, it's not about quality assurance.
Right.
It's about understanding your code base and delivering features that actually make sense.
Yeah. It's keeping the code so that it does what it should do, and keeping it also so that we can make it do the next thing that it needs to do without having to relearn everything from scratch every single time, right? We create abstractions because we can't keep 5 million lines of code in our head, but we may not even be able to keep 5,000 classes in our head, but we can keep maybe these 10 modules in our head. Oh, this is payments over here. Oh, this is warehouse inventory stuff over here, right? This is why we create boundaries, right? Bounded context, all these module boundaries, we create them because we cannot deal with 100,000 different things. An LLM can, but so therefore, like, if you're just going to have LLMs do stuff, then why create modules at all? It just gets in the way. Like, although they did, but then they have context windows and stuff like that, so it turns out that actually does help. But like, they can be arbitrary. For us, they have to have meaning, and without that meaning, and TDD is sort of a meaning building process, right? That mental model building meaning. Why is this here? Finding out, oh, this isn't supposed to be here, and what's going on. And so the fails in the predicted way gives us assurance that we at least know what we're doing if we're here. We just have an understanding of what's going on here. And when it does fail, if it ever does, we know that it's going to give us useful information. And that, like you said before, it's like, and if you write the test after, how do you know it fails? What I used to do is what's now called mutation testing, which is I'd go tweak, a line of the code. Oh, it fails. And I actually still do this just to sometimes assure myself that, does this test actually test this thing over here? Well, let me go and change this, reverse the greater than to a less than. At least this test should fail. If it doesn't, then I don't understand this test. And if this test fails and then a bunch of others, then I'm like, okay, that's fine. And if I change it and this test fails, but no other test fails, like, is that okay? Am I happy with that? Coverage is meaningless, but it's like, do I feel like this piece of information, this piece of logic is covered well? Those kinds of things really help. So I call this sort of manual mutation.
Yeah, the note on coverage is that some companies have this notion of, oh, we need 100% coverage, testing coverage of our software. And I always look at that as like, first of all, why? Second of all, are we living in a perfect idealistic world where things just happen magically? Because that's not realistic at all to have 100% coverage. And even if you go for that 100% coverage, what of it? What does it give you other than burned hours on building tests that test nothing?
Right. And that's the thing, is like, what is coverage telling you? It's telling you that this line of code happened to be along the way executed while I was running this test. It doesn't tell you anything about whether you actually validated that those lines of code did what they should do, what they were supposed to do. And
only that they're covered.
Only that they were executed. And those are two completely different things. Now, it turns out that if you do TDD from scratch, you will get 100% test code coverage, because by definition, if you're doing it well, and it's really hard to do well, I do not pretend to say I am perfect at it, because I will not write greater than or equals to make a test pass. I will write greater than first, unless there's a failing test that forces me to write that equals, right? So a 1 character difference means I might need to write another test. So by definition, I have never written a character of code unless a test was failing. So therefore, I not only have 100% code coverage, I actually have pretty close to coverage of like actual that it does the right thing. But that's, but code coverage to me is useful as a map, like, oh, this area has no test coverage. Okay, we need to focus on it. But other than that, I see, again, a quality gate of, oh, this code is really important. It must have 90% code coverage. I'm like, okay, you're gonna have people game stuff unless we understand what are you trying to do, and maybe there are some better ways.
Yeah, without the why, it's meaningless.
Yeah.
Absolutely.
Yeah.
All right, Ted, because we've been at it for a while, should we play?
Yeah. So let me quickly go through the rest of this, because then the game, again, it's like the game pretty much comes from this, right? So we write the least amount of code to pass.
Yeah.
Predict it'll pass. We run the test and it passes. Now you're good.
Yeah.
Right. And so in the game, that becomes commit code. So this is the game. So what's interesting is the original idea I had for the game was just to teach people that like 9-step process. Here are the steps in the order. And so the first idea I had for the game was like there's this memory game, right? You have cards face down, you look at 2 cards and try to match up cards, and it's like, oh, let me have people, here's cards, now put them in the right order. And so it turns out that actually I kept that as the sort of pre-start of the game. So you don't lay out the board right away. You basically get all the tiles, and the first job of the group is to put them in the correct order. So I did that for us, but but that's kind of like the precursor to the game. Is like, get people to collaborate, and so again, sort of the underpinnings of the game is like I want people to talk to each other and collaborate a little bit. And so putting it in the right order is basically the first step. And then we basically form it into this upside down triangle. And so here we see, right, what should it do? How will you know it did it? You write the code for the tests. And I'll talk about these orange parts here. So there's a few things about this board. One is you'll see sort of these exit criteria. So in order to exit a tile, right, because your goal is to basically move around from tile to tile, go all the way around and get to commit code. I forgot my commit trackers. How can I forget my commit trackers?
So, by the way, for those currently watching, this what you see is actually a live feed from a camera that's pointing on the desk. There's
you can see my hand.
There's Ted's hand, exactly.
And so so the goal of the game, at least initially, as I facilitated, your goal is to get to 5 commits, or if you have an hour, as many commits as possible.
Right.
And so you get, if you commit code, if you get to that slot, you basically discard your cards and you get your commit, and it's great. And so these 2, as I mentioned before, you basically leave those tiles by discarding a card. These, however, you have options. So one of the things I wanted to introduce in the game is like, what if I don't really want to write the code for the test? What does that mean? Well, it means you take on this idea of risk. Okay. And so I wanted to incorporate this idea of like, well, what if I don't do it? How does that affect things? Well, if you get to commit code, if you may not be able to read it on the screen, but basically is if you have risk, you have to roll a die. I have my dice here somewhere. And so if you have, let's say, 3 risk and you roll a die, you roll a 2, you basically have to revert all your work. And so it's like you're here and you roll a die because you had some risk. You basically have to, in a sense, go all the way back, and all the work you did has to be thrown away, and you start over.
Okay.
But
so now it's a game of risk management as well.
So because in TDD, like that's what we're doing. Like sometimes you can take shortcuts. Sometimes you say, I don't think this is, I'm going to use my judgment and say this part isn't worth testing. And if your judgment is good, then maybe that's not so much risk.
Okay.
And so, but sometimes you take risk and luck is with you and it passes all your integration tests and you check it in, but it's this sort of landmine that's waiting for somebody to step on and have bad things happen. I need to come up with a better metaphor, but basically it's something that somebody is going to run into, and it might be you 3 months later or 3 years later.
Okay.
And so at these points, you basically have that choice. So if you're here, you can skip ahead to writing your code for the feature, because of course that's what we want to do, is that's all we care about, is writing the code for the feature. And so you can skip ahead, you can take on risk. If you skip ahead from here, the idea is that there's a little bit less risk because you predicted, so maybe you had a good mental model. It does, games don't always precisely match with reality. So here I sort of fudge things a bit. And so, but if you want to go the TDD route, you basically have to write your code first. So you're writing test code, and then you have to predict. And so that's where the cards come in. So you basically, I already dealt cards for us. And there are a bunch of different cards. So there's a write code card. There is a less code card, and we'll look at that. And there's the predict card. There happens to be a refactor card. What's really interesting is that even though, as I said earlier, refactoring is such a key part of TDD, it actually in the game, it's reduced to sort of this one card, which makes me sad. And that's why I'm working on a refactoring expansion, a whole separate expansion pack for refactoring. But for now, it's a card. And one of the things the refactor card does is if you've taken on some risk, it can reduce risk. But there are also times when things happen. So there's a code bloat card. And this affects your ability to basically predict, right? The more code you have, the more code you've written, the harder it is to predict, right? If there's one line of code, that's relatively easy to predict. If there's 100 lines of code, yeah, you can predict it, but it's going to be harder. You're more likely to make mistakes. There is another red card, what I call a tech neglect card, after Kevlin Henning, because I don't like tech debt. I like tech neglect. As a term. And so this card, this can't assert card, is basically like, remember that part where it's like, oh, I need to test this code, and so, oh, I can't even access the piece of information I need. And so it's basically can't assert. And so this basically, you get stuck or you lose a turn unless you have a refactor card, right? Because the way you solve this is you refactor the code so you can access that. And so again, this idea of trying to incorporate these ideas into the game. So anything else? So you basically write code, right? So the order of operations, right, is you write test code, you predict, and that's when these test results will come in handy, and we'll actually see those when we play. And then you basically write the production code, and then you predict. All right, so you get here, you predict the test will fail because you haven't written any code yet. Then you write the code for the feature, and then you predict that it passes. And each predict stage requires you to play a predict card, and there's a chance your prediction will fail. That's what those test results are for. So,
well, you made me whip up my box with dices, so I'm going to grab a D6, maybe a red one today, and let's have a roll at it.
All right, so I'll go first because that way then you can follow. So this will be my hand down here. This will be your hand up here. So the first thing I need to do is discard a card. So I'm going to play. Do you want blue or yellow?
Yellow is fine.
Okay. So I'm going to discard a card. So I have to figure out which card I'm going to discard. I'm going to discard Refactor. So I'll put that in the discard. And I'm going to move here. And so now I need to discard another card. I'm going to discard the Write Code card. And then I move here. And the rule is again, your turn is over basically when you have 2 cards left.
Okay.
And so I am now in the Write Code for test stage. So I have the choice of either taking on risk or to exit, play a write code card. So I'm going to play a write code card. I'm going to move these down here. We'll track those later. So there's this idea of, right, just like we have sort of code that you're working on, right, code that hasn't yet been staged or committed. This is sort of your workspace area. This code bloat hangs out here and actually affects things, which we'll see. I'm now down to 2 cards, so my turn is over. And so I basically get 3 more cards. And I wrote code, so I'm over here, and it's now your turn. So you tell me what you want to do. These are your cards. Which card do you want to discard?
Right. So, what's the significance of less code?
So in order to make your predictions more reliable, right, when we write code, you can write a whole bunch of code or you can write less code. And so the idea is, the way I incorporate it into the game is, you play a write code card and then you can play less code on top of it. And that basically sort of the idea of, I've written actually less code to get this thing done.
Okay. So for the moment, I'm probably going to drop less code.
Okay.
To move to... Yeah. And now I need to discard again to move forward to writing the code for test.
Right.
So
you probably don't need 2 write code cards.
Yeah, that seems reasonable.
Yeah. So we'll discard one of these. So
Mm-hmm.
now you are here, and now you need to play a write code card. So you've got one of those. So you can totally play one of those. So we'll put that here in your play area.
Yep. Okay.
And now you have 2 cards left. So you're moved here.
Mm-hmm.
And your turn is over. So I will give you 3 more cards. And we'll flip these around.
So 1 turn is 3 actions.
So 1 turn is discard or play down to 2 cards. Because if you decided to take a shortcut, right, moving the pawn actually by itself is not part of the turn because that got too hard to track. So the rule is really simple. In fact, I have people sort of chant it when I'm teaching. It's like, how many cards? 2. It's like, so playing it's like if you see 2 cards left in your hand, you know your turn is done.
Okay.
All right. So I'm here. To exit, I can either so I need to predict. So I have a write code card. So you can't predict unless you've written some code. We've written some code. I could write some less code, but I'm just going to do a predict. So I basically play a predict, except I've got this code bloat. And so that means there's a bunch of code. So I'm going to basically cancel that out. So there is a way to say, I'm going to cancel this code bloat out, and you basically play less code on top of it.
Okay.
Right? So I basically have done a little pre-factoring to reduce that code bloat. So now I'm going to play the predict, and now I pick one of these test results cards. And so what that says is, in order for it to be as predicted, you have to have 2 or more less code cards. So this is basically saying, if you didn't write really minimal code, it was unexpected. And so since that's my situation, I don't have any less code cards. It's basically unexpected. And so this is where something went wrong in my mental model, between my mental model and the way the code is. And so we basically have to represent that by now my predict is blocked. So, which means, and this was the recent rule change that I made, it's like predictions, it's not like there's a flaky test. Yes, some systems have that, but in this game, there's no flaky test. The prediction failed for a reason, so you, again, have to spend effort, do work, do some thinking. And again, as I've said, the game simulates that idea of thinking of discarding a card. And so in order to basically get past this block, or basically do the thinking of like, what went wrong? Is it my test or my code? I have to discard a card. So I'm going to actually discard the write code, sorry, the refactor card, because I won't need that for a while. So I'm going to discard this. Right. These go away. I'm unblocked. And I'm down to 2 cards. So basically my turn is up. So next turn I'll have to predict, but I basically don't proceed. All right. So now it's your turn. So you need to, if you want to take risk, you can take risk, or you basically need to, you can play a less code or you can play your predict card.
I would go with less code.
All right, so we'll stack that on top of here.
Right.
And so your goal is you want to exit this. So in order to do that, you'd have to have a prediction.
Predict.
Yep.
And so let's go with predict.
All right.
Yeah.
So we'll play the predict. We'll pick and see what the test results are. It says one or more less code and card in play, and your prediction succeeds. You do, and so your prediction is good.
Hey!
And so we basically clean up that work. That gets discarded. That gets discarded. And you were yellow, right? So we move you ahead.
Yes.
And so now you're here. So you have 3 cards left. So you've written the code for the test. All that's working as predicted. Now you need to write the code so that the test compiles.
Right.
So you have a write code card, so you can play that.
Yeah, I'm going to write some code then. Yeah.
All right. So we'll write some code. You move ahead to here, but your turn is up because you've got 2 cards left. And so now
all right.
I'll give you 3 cards. And we'll put those here. All right, so it's my turn. Oh, I forgot to take 3 cards. Oh, I did that out of turn. We're just playing.
That happens.
That happens. So I am here. I need to exit. So I'm going to play less code. And actually, I'm going to play another less code because I really like minimal code when I'm writing stuff. And now I can predict. And so I'll pick this. And it turns out it was as predicted. So one might say I wasted effort by writing less code, but I like to think of that as like, no, I've left the code in good shape. So this gets discarded.
Right.
My prediction succeeded. But since I played those less code cards, basically my turn is up. Right, that was a lot of effort, right? So it took effort to write less code, to write more concise code, to write less than you think you need.
Yeah.
And again, the game tries to emulate that. All right, so it's your turn.
So now we're in a predict test will fail.
Right, so you've written some code.
Yeah.
And you have some less code cards that you could play, but you don't have a predict card.
Right, so either way, I have to play cards because I'm not going to be able to progress.
So your choice is you can either play cards or you can discard cards. You just have to basically get down to 2.
So given that I would have to either discard or play, then I'm going to just play 2 less code.
Yeah. May as well
and then drop discard refactor.
So one of the things that often comes up when people are playing, and usually I have 4 to 6 people in a game, is, hey, can we trade cards? Because at work, if
we trade tasks.
We just say, hey, can you come over here and help me with this thing?
Right.
And usually people are say, sure, give me a minute, and then I come over and I help you. And so this was one of the rules that came up again out of somebody saying, hey, can we trade cards? And I'm like, sure, let's see what happens. And so now that has become codified as a rule. And so one of the things that I do when I facilitate this game is I start changing the rules in the sense of, not changing the objective of the game, but like, okay, now you can trade cards. So the rule is you can trade 1 card per turn. So we'll pretend we already knew that rule. I'm going to trade a predict card with you for a refactor.
Okay, right? Thanks.
And so now you can predict.
So you came by just to help me predict what the hell is going to happen.
Yeah,
all right.
You're
let's
like,
predict.
Yeah, I don't know what's going on. Let's predict. Okay. And so since you've got 2 less code cards, it's likely that your prediction succeeds. 2 or more less codes. So good thing you actually did that work. It sometimes pays off.
Yeah. Sometimes, yeah.
So as predicted, so you're here. We gather up all these, we discard them, and we give you back up to full. But there was a code bloat card, so that goes here.
Oh no!
Right. As you were preparing for your next task, you discovered some code bloat. So that's part of you'll have to deal with that on your next turn.
Yeah.
And so I'm going to sort of shortcut so usually we play this over like an hour. When I do the workshops, it's an hour and a half. And so I let people, get an idea of going sort of around the board at least once. And then I, started introducing you can trade cards, so people notice that they're going. One of the things and this is something that I didn't design into the game, but because of this feedback loop of watching people play the game and having them suggest things, more and more the game has become not just teaching you the tactics, but also what does it mean to work together as a team. So trading cards, yes, we do that at work. Hopefully people don't sort of deny you, help. And we maybe talk about that. But also sometimes we pair. I love pairing. Actually, I prefer working in a mob and ensemble. And so one of the things people say is like, hey, can we pair? Like, especially if I'm in this came up in the Agile Open Northwest because there's a lot of extreme programming folks there. And they said, hey, can we pair? And I'm like, sure. And so one of the things that reveals is, and this is really interesting, is that these pawns don't represent you. They represent the work that you're doing.
Right.
But we often, associate ourselves with our work. And so I say, no, we're not, that's not you, that's your work. And so when we switch to pairing, what happens is one of the pawns goes away. And it's like, now you're both working to move that pawn forward. You take a turn, you spend some effort, move the pawn forward. I do some work, I spend some effort to move the same piece of work forward. And I wish I had designed that into the game, but it came out of suggestions from folks.
So basically, each of the players still has their hand, but they now move a singular pawn because now they're working on the same feature.
Exactly.
Right.
And then when I basically, towards the end of the whatever time block I have, I then say, okay, now we're ensembling. Everybody's, there's now only one piece of work, one pawn on the board, and we are all working together to move that forward. And one of the things that they almost feel viscerally, right, coming back to this experience, they experience, wow, we're making commits so quickly. It's like, yeah. And it turns out that you can move around a lot more quickly when you're focused on one piece of work and finishing it as a group than you are as separate individuals. But we can we'll get to we can do the pair now, or we can basically keep working on individual work. You tell me.
Let's continue on individual work for the moment.
All right. So I think it was my turn. And so I'm going to exit, I play write code. So I'll write some code.
Yep.
And then I need to predict, but before I do that, I'm going to play less code. And now I'm going to predict. And my prediction is 2 or more. So my prediction has failed. So I need to go and figure out why it failed. Whoops. So that blocks. And my turn is up. So I'll have to deal with that next time. So as Arthur, the other facilitator, says, like, your day is done. You spent a lot of work. We're trying to figure out why this predict fails. Go home, get a good night's rest, and come back fresh tomorrow.
Yeah.
So I'll take 3 cards. And I've got a can't assert that will affect me later. I'll leave that. Leave that over here. And so I need one more.
Can't assert. That's a new one.
Yes. So can't assert is, again, that idea of you basically get stuck here. Like, how will you know you did it? And I'm like, I have no idea. I can't figure that out. I need to go do some work. And I need to, the refactor card can help, or just spending a bunch of time exploring and thinking, and maybe it's not refactor. So my turn is up. It's your turn.
Right. So I'm in the predict test.
So you need to first write some code. So
Oh no, write code. Sorry,
yeah,
we're in the feature.
Now you're doing the thing that everybody wants to do, which is write code for features.
Yay! All right, let's write some code. Absolutely.
Right. Now you've got some code bloat that you have to deal with. That's going to make the test hard to predict. So what would you like to do
for
about
that?
So the less code will basically cancel that out.
Right. If I leave it, that basically increases.
Yeah. So technically, this subtracts 1 from the less code, and so technically, the code is now unpredictable.
Right. So now I'm on minus.
Yes.
Right.
You basically have minus
so
1.
It becomes unpredictable.
Yeah.
Okay.
I mean, you could see maybe it's as predicted. You could do a predict, or you could do less code.
And refactor doesn't work here, right?
Right, because refactor must. So one of the things you'll notice is that these tiles have colors around them, and the only place you refactor is when you're in the green, right? We don't refactor while we're in the red. Well, I do, but I'm a professional, and I know what I'm doing usually.
Usually.
So one thing that's interesting is, remember I talked about this idea of tests failing as predicted. In a sense, that's in the green. I'm okay with refactoring there, but for the purposes of the game, you can't refactor here.
Okay. So in that case, well, if I know that there is a code bloat, I would probably say, yeah, let's work on it some more, so to reduce it. And to reduce it, I need to consume my only less code.
Yep.
And to deal with that, then now I need to predict to try to get out of it.
Yep. So predict. And nope, you needed one or more less code, so that blocks you there.
Right.
Your turn is up. And so you get 3 more cards.
Sure. So I think that from the concept so far, the thing that I would probably struggle the most with is the predict part.
Yeah. Yep.
And I think that would be, for a lot of engineers, developers, that would be probably the most annoying and complex thing to deal with.
It is. It is, yeah.
All right.
And even if you were sort of doing TDD, like there are lots of folks who do TDD who don't do an explicit predict. And when you do a predict, one of the things you have to do if you're going to do it, and let's say you're doing it by yourself, one of the things I tell people is, like, even if you're by yourself, say it out loud, because one of the things our brains are really good at is thinking things and then immediately seeing the results and changing what you thought. But by saying it out loud, you're like, I think this is going to fail because it's going to be 0 instead of 10. And then it's -3. And you're like, oh yeah, I thought that was going to be that. And it's like, well, no.
No.
So by saying it out loud, it's like, oh, all right, yes, I was not correct.
Okay.
Because there's no, like, it's not cheating, and it's not like you're not being graded by how often. The prediction idea is to set yourself up to notice things, because a lot of times we run sort of on autopilot and we do things without thinking about it. And for me, it was a very hard habit to build, to say I will always predict before I run the test. And on stream, since I'm always saying stuff out loud, it's I can't hide. But sometimes I will forget to predict. Like, I've been doing it for years, and sometimes I still fail. Get so caught up, and I want to see the result that I will fail.
This needs to be practiced, otherwise you will not get the habit of doing it.
Yes. Like most things, yes.
Yeah. Okay. So now it's your turn.
Now it's my turn. So I'm here to exit. The test needs to. So I'm blocked on the predict. So I'm going to go discard a card. So I'll discard that one, and that unblocks me. And so I've got a write code and a less code. I'm going to write less code, and now I'm going to predict. And so at this point in the game, people start recognizing, oh, if you've got 2 less code cards, then your prediction is always true no matter what. This time I got an as predicted. But the cards are basically, as you play the game, you learn, oh, as long as I've got 2, I'm always good. And to a certain extent, and people have said this, like, well, then it's boring. It's like, yeah, coding should be kind of boring. It should be like, I do this, and I do this, and this is what happens, and I go on, do this, and everything flows along, and it should generally be kind of boring at that point. but you still get the sort of the hits of like, yes, it does because what that doesn't account for is like in the real world is a lot of thinking involved at each step. And then it's like it turns out to be, oh, good, my thinking was correct, right? And then,
coding things is actually the last the last mile of thinking about all this, how to actually implement it.
right.
So coding is actually extremely boring. The getting to that part that you can actually code is the interesting part, because that's actually where the problem domain is, right?
Exactly.
Code is just a manifestation of our understanding of that problem domain.
And I think what I see a lot, and I talk about this a lot, is people find ways and sometimes look for ways to make coding more exciting by doing all sorts of interesting, complicated ways of doing things that are completely unnecessary. Like, oh, let me use a bloom filter here because I've just read about that and those sound really cool. It's like, no, like there are 10 things here. You have to see if there's one of 10. Like if you have 10 million, okay, use a bloom filter, but like 10, come on, what are you doing?
Because basically,
if you're bored with the code, you're going to find ways to make it interesting.
Sure, but that basically is resume-driven development, right?
Yes. Yeah, and I to a certain extent I blame the QCon conferences because like really good material and they're well done conferences, but I think they led to, oh, Uber just did this or Netflix just did this, let's go do that too. And
so we're going cargo culting.
So we're like, so again, it's like, yeah, we're doing stuff without understanding the why. We don't actually have that why, but we're going to do it anyway because, and I think for me that it hit me when I was working for this San Jose County jail. We were helping automate some paper stuff, and it's like, this is a really interesting domain. Like the goal was, how do we release people who are not gonna, who are not violent and so on? How can we release people so we don't put people in jail that just need to wait for trial or whatever they're waiting for? And so how can we do that? And such an interesting domain. And it sort of hit me as like, if the domain is boring, it's likely, well, maybe the domain is kind of trivial, but usually they're not. And if you really explore the domain, and this is why I think developers being distanced from that experience of what are people using it for, they tend to say, oh, the domain's boring, let me go find interesting stuff in the code. But I think if you really connect with the domain and really try to understand it, I think domain-driven design has helped a lot in that area. Then you say, oh, wow, the domain is really complex and interesting. And I want my code then to be as simple as possible to fulfill what the domain needs. And I think that's the right ratio. But if we get disconnected from the domain, and especially, if you're doing like, I'm doing integration, like I have no idea what these things are, and I'm just kind of wiring stuff together, you're going to look for interesting ways to wire stuff together. Oh, let's use Kafka here. It's like, what? There's like 2 messages an hour. Like, what are we doing here?
And why are we using a streaming broker instead of an operational broker?
Right.
Yeah,
exactly.
but see, that's from perspective of domains. If I look at my work as an integration architect, I never have a business domain. I always am in a technical domain of integration.
Right.
This is not building a domain system ever. I touch several domain systems, but I never really built a domain system. And in the 15 years of my career, the only code touching any domain is actually literally all the automation that I'm doing for myself, rather than anything that I do at work. Because this is literally a supporting domain in terms of TDD. And it has no domain logic, or it should not have domain logic, because it's there to support the core domains.
Yeah.
So if I'm looking at it from this perspective, yes, I'm not embedded in a specific business domain, but at the same time, I have access to all business domains.
Yes.
And it's like extremely interesting to look from perspective of language. If you do domain partitioning on an integration platform, we have customer here and we have customer here. Why the hell are they different? What's the reason for that? It's like you go exploring, and that was one of the most amazing things that I found after years, that this was actually one of the aspects that helped me grow into various aspects of the role really fast, because by nature I'm a very curious person. So of course, when integrating systems, I inquired, what did they do? How did they do it? Why is it this way, not the other way around? What is this object? Why does it behave that way? And then I suddenly had knowledge about a whole telco company because of that. And because I spent in that company about 8 years of my career, first as a consultant, then as an architect in-house, it was like, oh, I actually know a lot about telco just because I was in the middle of it between all the domain systems.
Right.
And code was extremely boring.
Right.
It was really repetitive, because we had coding standards that we literally validated at the time in the first ever CI/CD in the company. We had SonarQube literally reading the code and saying it's up to standard or not up to standard.
Right.
So that was extremely boring.
Yeah.
But digging into the data models and figuring out how the data flows and why does it have to be orchestrated here and there, etc., that was amazingly interesting.
Yeah, and the domain doesn't necessarily have to be purely business, right? There's always going to be, technical domains. I was working on basically our test runner architecture when I was at Guidewire, and like, what was my domain? It was test running, but that's my domain. Like, yes, it wasn't the insurance software, but it was like, how do we more efficiently and effectively run our tests and manage the machines and provide feedback to developers. And so it doesn't have to be a quote, the domain of the company in a sense, like what the purpose of the company is. There is some domain that is not just, writing algorithms. Sometimes it could just be, like you said, it's like, sort of like, what is the data model? What's the needs here? The claim system needs a policy, which is different than the billing policy point of view, right? And this is where you get into the bounded context and things like that.
And just quoting Barry O'Reilly here, because Barry, I don't know if you know that, Barry used to be an integration architect.
Oh, okay. I didn't know that.
Yeah. He used to work on BizTalk, write a lot of things in terms of integration. And Barry told me that when he's hiring for Black Tulip, if he looks on a CV and he sees integration architecture anywhere there, that's like in years, that's like 20 times the value for him than like JavaScript front-end work, right?
Yes.
Because of the amount of complexity. And I asked him, well, okay, what about me? I spent 15 years in the field of integration architecture. And he was like, you're a masochist. But then my interest in the field is like, how do we interact? Why do we interact? So the code is extremely boring and repetitive, but the reasons for interactions and how we interact and how we design the way we communicate between various systems, that's the actual domain. And that makes it interesting, then manifests in code, and we see that working. And then, yes, you can test it in all sorts of ways. And prepare those tests and write those tests, and we have unit tests for integration, like in MuleSoft they're called M units, and we just bake them into the repositories, run them with the repositories, and prepare them every single time. And I think that while I wasn't like convinced while preparing for this session today that TDD would be applicable to integration, no, it's absolutely applicable to integration. You could actually really teach that engineering mindset of integration through TDD, because it is a different way of thinking than writing domain-specific code, as in business domain-specific code. So that means you need to really think about what you're doing, and that engineering mindset is often lacking, especially in junior developers. And in integration, it's 10 times more visible. So you basically now gave me a tool to have a chat with my developers, to play a game with them. It's like, yeah, okay, let's play it, and let's see what does that translate to in our reality that we're working in. So that's great in that sense.
And it's really interesting because one of the things that says a gentleman by the name of J.B. Rainsberger, who's also another I look up to as a TDD expert who I learned from. And I don't know his exact quote, but it was basically something like, it seems like TDD is going to slow developers down. And he was like, maybe that's a good idea, right? Because that idea of like, we're perhaps not thinking enough. We're just doing, and that we're not consciously thinking. And I think that maybe we, and especially with LLMs, like, oh, now we can go really fast. Like, well, that's even worse because when are we, and Jason Gorman, another guy with XP stuff, talks about, we learn from feedback, but we need the feedback, and we need in order to learn. And if we're just pushing out stuff, we're not actually, there's no time. So we need time to think, and we need time to get feedback so that we can improve our thinking. And then the rest of the
Polish,
stuff.
In Polish language, there's this idiom that you're running with an empty wheelbarrow, right? So basically, we got ourselves so busy that we're literally running with empty wheelbarrows, and we don't even have time to load them. Right? So this is like the equivalent of that speed up without thinking through the consequences, thinking through the design, just coding according to instruction that you never validate, and just going forward. About moving forward, is it my turn by chance, and you should take some cards in? Because you have only 2.
Yes. So I just moved my prediction. Did my prediction succeed? Yes, my prediction succeeded. So let me get rid of these.
Yeah, you had as designed, right?
Yeah. And so I will give my hand back to full.
All right.
And yes, so now it's your turn.
So
you're blocked here, so you need to discard a card to release that block.
Oh, okay. So the as predicted block, it can be discard through the discard.
Yeah, just discard it. Discard any card.
Yeah, right code, discard it then, because I have 3 of them, so I don't really need them. So that basically means that now I predict again.
So you can predict again, or you could trade a card with me, because maybe you want a less code card.
Yeah, I think I could use some less code here. You have 1, so if you were willing to help me out to reduce the code, that would be great.
I'm willing to help you out, and I'll take a right code from you.
Sure.
So now you can play that.
Yep. And then let's play predict.
Yep. Let's see what happens. And yes, 1 or more. Good thing I helped you out. Because
yay! Also,
so
code consulted, improved, and let's get going.
And so your turn is now up, but you get to move to. So you did the right code. So you're actually here. So you are at commit code, and you did not take on any risk, and so you basically
any roll is a winning roll.
Yeah, so you have to get more than 0.
Yeah, but I basically throw 6 anyway, so.
So we basically discard your hand. If you had any risk, you could actually spend the refactor, but there's nothing nothing to do there, and so we basically discard that, and you get a commit. So we take our commit. And
what's an interesting thing that I already see from this game is that you actually see the workload flowing.
Yes. Yeah.
Because if you take risks, you actually see where that workload will later land in that refactor, that you need to spend more cards, even more if you're unlucky.
Yes.
To actually deal with that, and then you go back and I cannot move forward because my risk is too heavy. Yeah.
Yeah. And that's the other thing about the game that, again, I originally intended it to be just like learn the tactics so you can do TDD. But as a technical coach, it provides all these great, or as a tech lead or whatever. And I know lots of folks do this, and I've got some folks who they bring it to every conference and they play it is a provide like. And I see this with board games in general, right? Like I've been to conferences and people are playing board games because it provides a wonderful opportunity for talking. Like,
yeah,
I know for me, sometimes I have a problem from just sitting around a table and maybe we're eating or something. Sometimes it's hard to generate conversation. But if you're playing a board game, especially if you're playing this game, it's like now we have a focus and a topic to talk about, and the things that happen, we can talk about it. And so the games take a long time, not because the game itself is taking a long time, but because you're always having these great discussions.
Yeah. I mean, that's one of the things I absolutely hate about my wife when playing board games. For her, the conversation is more important than the game, and I would just like to play the game. Of course, I enjoy a conversation, but
it's like, damn it, let's
please,
play the game.
the balance, please.
Yes.
But yeah, it's. I mean, if we're trying to learn something, and this game is designed to teach us TDD, that the fact that we're actually having conversation over what we're doing in the game actually matters more than the game in this sense. So this is actually great.
Right.
But then again, purpose, entertainment or learning, right?
Right.
Learning wise, awesome.
Yeah.
Entertainment wise, come on, I want to progress with my game.
Yeah. And it's really interesting. I'll facilitate this, and sometimes it'll be like, can we stop talking and move forward? I want to get more commits. So like there is a bit of both, but it's especially when once you go around once and you get the idea of the game starts moving much faster, and then you have sort of a bit less conversation. But the power of these things to promote that conversation and see, yeah, we do this, maybe we should try this, to me is like, that's worth it. That was worth all the effort, is when I see people relate it to how they currently do work and maybe how they can do it better.
Right. It's your turn then.
It is my turn. So you
yes.
got 1, 2, 3, 4. You get more cards. And I need to I think I must have. This is the problem. Is like sometimes I lose track. I did a predict, and so I forgot to move my piece.
Oh yeah, you forgot to move the
okay.
yes to.
So I write code, do that. I'm just going to predict.
Sure.
I feel good. Oh, too bad.
You feel confident.
Nah. See, we think we know what's going on. We don't. So I'm blocked. I'm going to discard this card, so that unblocks me.
Yeah.
And well, my turn is up. That was a lot of effort for not feeling like I made much progress, which is sometimes how our days feel, right? Oops.
Yes.
Yeah, I just lost some cards.
Especially with ADHD.
Yeah.
Brain all over the place, and then you're like, what did I actually do today?
All right, so your turn.
Right.
So you basically need to. So you're back here.
Let's see. We have, what do I have there? Write code, predict, and less. So, 2 less. I'll drop one of the write code, and then I'm going to drop one of the less.
Move here, and then drop the less, and then move here.
and then I'm going to write some code.
Okay. And write some code. Oh, you got a can assert. Luckily, that won't hit you up until later, so I'll just stuff that up the side.
Yeah, you're going to be hit by can't assert later, earlier than I do, right?
Yeah, that's right. I'm coming up to it. This code and write code. Okay, so my turn. So I need to predict. Hey, can I trade a card with you? Can I trade a predict for one of your less code?
Yeah, sure. I got plenty less code, so let me help you out.
All right, so I'm going to play a less code, and now I'm going to predict. And it says 2 or more. That was some bad code. So I'm going to discard one of those. That unblocks me. And again, I really feel like I made no progress. Boy, this code is sometimes hard to work with. Oh, and I got a code bloat. Oh no. Well, that cancels this out.
Oh man. Okay.
All right. Sometimes you're working in a code base and it just takes you forever to get through parts.
Right. So now to progress, I need to write some code.
Yep. Or you could take on some risk.
No, I'm a risk-averse person. I'm gonna write some code.
So actually, sorry, you should be here because you wrote code already.
Yeah.
Okay, so now you need to predict or replace.
Oh yeah.
Code.
Then I'm gonna do less code twice and then predict.
Okay, so let's code, and predict, and we know what's going to happen. No matter what, you're going to succeed, and you do.
Yep.
So this goes away. Here. And you are now here, right? So as expected, and your turn is up. So
yes,
3 more cards.
So how many cards there are in the deck?
There are 90 cards in the deck.
As in both decks, the game deck and the test result combined, or is it?
No, sorry, just the these are the action cards. So there are 90 action cards, and there's 18 of the test results cards. So
right,
probably gonna need to shuffle the action cards soon. All right, so my turn. Pass as expected. So I'm gonna play less code, and I'm gonna predict. And one or more, which I have. I have one or more, so I get my prediction succeeds. I now finally understand the code base and my tests. So I move ahead here, and I can commit code. So basically, I don't need any of these. I discard all of these and take on a commit. And then I basically get a new set of cards. 1, 2, 3, 4. And we'll shuffle the deck. And so now we both have one commit.
Nice. Okay, so I'm at writing code so the test compiles.
Right, so
I have 4 predicts. Seriously, goddamn. I guess I'm gonna write code and predict.
Yeah, so there's always I'll just write code, predict, and see what happens. And nope. So your predict blocks. So you need to discard a card to get rid of that block.
So I still have 1 card to go. So I'm gonna discard to remove the blocker.
All right. So we'll discard this. That goes there. That gets discarded. That gets unblocked.
Yeah.
And that's the end of your turn. So we got 1, 2, 3 more cards. And now it's my turn. So I need to discard. So I'm going to discard a write code. And I'm going to discard a predict. I'm here. So now I'm going to, you know what? I'm usually risk averse, but I'm going to take on some risk. I'm going to jump all the way to here.
Ooh.
And so now on my risk tracker, I'm going to need to add on that I've taken on some cycle risk. And I still have 1 card to go. So to exit, play write code. So I'm going to play a write code. And I go over here. And now it's your turn.
So what about your can't assert?
So this affects me when I get did I not play that? Did I?
Yeah, you skipped that.
I might have skipped it. Oops. All right, let me roll back. So it's interesting. The online version of the game, I have one of the primary features is undo. Let me. So I undid. I was here. So let me take back one of the discards here. So I'm here. So the can't assert, basically, I either have to refactor. I don't have a refactor card, or I basically lose the rest of my turn, which means I have to discard back down to 2, and then I get that. So now basically I don't go anywhere. Now it's your turn.
Okay. So now I'm in the area of write codes to the test compiles. So I'm guessing I'm gonna do less code and predict.
Yep. So less code and predict. And
let's see what the prediction.
Let's see what prediction says. As predicted.
Yay!
So you're all good. So your
So I
prediction.
wasted the effort, but
Well, it's never wasted effort. I mean, it's always, it's
nah,
like, do we believe that we write code and try to write good code because it always is useful? I mean, we have to balance things out, but we have values and
Uh,
ideals.
in architecture, I have this notion of not really aiming for the best architecture, but aiming for the least worst architecture.
Mm-hmm.
Because the notion of best architecture actually creates over engineering.
Yes.
All right. So to finish my turn, I'm just going to write some code.
All right.
And let's have the end of the day.
Yep.
Drink a beer and come back to this in the morning.
Yep. And lots of predict cards.
Ouch. That's going to be painful.
All right, so my turn. So now I'm going to discard.
Yep.
And now I'm going to take on the risk. And so this gets to 3. And so now to exit, I need to play a write code. I don't have a write code. So I'm going to discard these 2. Oh, wait. So what happened was I wrote code, but I took on risk. That gets discarded. That work gets thrown away.
Yeah.
Discard those. And oh my God, all these less code cards. Oh, code bloat.
Oh no.
All right, finally a write code and another write code. So, all right. So you've written code and you need to get a successful prediction. Remember, we can trade cards if you'd like.
I'm happy to trade you less code for a prediction.
All right, that's good deal for both of us.
Probably.
And I assume you'll want to play the less code then.
Absolutely. And let's try to do the prediction and see what happens.
Right. Let's see. And it's as predicted.
Yay!
Yeah.
A very nice, clean piece of code, and
All right.
further.
And so you have no risk, so you got to commit, and so now you've got 2 commits.
Yay! I'm going ahead. I'm guessing that for the most part, being risk averse actually speeds up a lot of things in the game.
Over the long term, it helps. When I'm having when I only have like an hour, it seems like taking on risk helps. But that depends on the roll of the dice. But long term, you get to the point where you need to actually address some of that risk. And the refactoring cards really help.
But you can still pass with maximum risk, right?
Well, so what happens is you take on cycle risk. So I took on 3. And if I succeed here, then this becomes baked into the code base like that. And so then if I take on more risk next time, that's how it does. Then it's pretty much impossible, because how can you roll higher than a 6 with a 6-sided die? And so you basically end up sitting here waiting until you get some refactor cards so you can reduce your risk. And so you then spend a lot of time basically cleaning up after the mess you just made, and that might sound
and it's like if you don't get the refactor, then basically that would be kind of a representation of, now I need to understand what the hell I baked into that code that made it messed up so much that I cannot progress anymore.
Yep.
Right. Yeah, because that kind of is like let's say, from examples from my work. Great example. There was a team that was supposedly building an integration platform. What they built was an MDM solution with a lot of Azure functions covering it around. No SQL database with MDM functions. And basically, they made so many customizations there for each model that at a certain point, they basically spent 80% of time fixing and maintaining it instead of building new functionality, which is exactly that kind of notion that you have with the high risk. They accumulated technical debt and risk that they now needed to remove by removing that risk by refactoring. Which they had a humongous problem doing, because now they had to wait for those refactor cards, but that basically represents that trying to understand and grasp what's going on, or spending time on operations.
Right.
Hey, that's a good analog.
Yeah, yeah.
All right. I'm grasping the concept here. Okay.
So let's see. So so you just got the commit. So I think it's my turn.
Yeah. Yes.
But let me give you your cards. I'll give you one too many cards. Oh, you're lucky you got a refactor card. That'll come in handy when you need to address your can't assert. All right, so I need to write code. So I'm going to write code. I need to cancel out my code bloat, so I'll do that.
Yeah.
And then I'm going to play less code. And that's it. That's all I get to do. All right.
All right. So I discard. What was that there? I have less code and write code. Or how much of which?
So you got 3 write code cards.
Ooh.
And a predict.
Yeah, then I'm discarding the write code, and then I'm just dropping the refactor to get the can't assert out.
Yes. So now you play this. This cancels out the can't assert.
Yep.
And so now you have one more discard.
I need to discard. Yeah. So in this case, I'm going to discard write code.
Okay. And so now your turn is up.
Right.
Less code. Less code. And another refactor. So I've written less code. I'm going to write a little less code, and that way my predict is going to succeed, which it does. Those get discarded. And now I'm here. Actually, I'm here because I wrote and I predicted. So before I commit code,
roll the dice.
Well, so I can basically sit here and say I'm not going to commit yet, and I'm going to discard this card so I can maybe get some refactors, and maybe I'll trade a refactor with you.
Oh.
And so
you can reduce the risk.
Yes.
By refactor.
Yes.
Oh, okay.
And so one of the rule changes was currently the refactor card says it reduces risk by 2, but I just changed that because it used to be 3, and then that was too much, and then I changed it to 2, and it's like that was one of the other but that was one of the other balancing things. It's like, no, I think I'm going to make it 1. So because otherwise people would take on risk and then just wait for refactors that would easily cancel it out.
Remove it. Yeah. And the reality is that refactor doesn't really remove it that easily.
It's a little harder than that. Yes. Yeah. So can I trade a I don't know. I'll trade a less code card for your refactor?
Sure. Yeah, why not? I'm going to help you refactor.
Yeah, but I'll have to wait until my next turn because. So you are here. You can take on risk, or you can play write code to exit.
Again, risk averse, so I'm going to write some code.
All right. Write code.
Yeah. And now I'll need to predict. So I'll first go with some less code.
2 of them?
No, just 1, and predict. I'm feeling confident about this one.
All right, let's see. And nope, 2 or more.
Shucks. Okay.
So
all right, so I'm stuck for a moment.
You're stuck for a moment. Yep. There's another refactor. Oh, I might trade that with you. So I currently have. So I'm gonna basically. Can I trade up my predict card for your refactor?
Yeah. Happy to help you with some refactor.
Helps you too, because you're going to need another predict.
Absolutely.
All right, so now I'm going to refactor, so it reduces risk by 1. And then refactor again, and reduces risk by 1. Now I think I can go ahead and try to see if I can commit. So I'm going to roll the die. And so
I have a pretty decent chance.
I need basically a 5 and 6 chance.
Yeah. Sorry, your risk just materialized
Oh,
and hit you in the face.
oh my gosh. We could say what is the chance of that, but we know what the chance of that is. It's a 1 in 6 chance. So basically, I go all the way back around, and I don't get my commit. So that did not pay off.
Oh, you should have waited.
Uh,
Okay, so if you hit the risk, then you roll back entirely to what should
yeah.
you do?
Including the risk, because I took on the risk, and now whatever I did that took on that risk, that goes away. And so
Yeah, all right.
that's
Because
the other
now
way
you
of
need to
reducing
do
risk, is you abandon your code.
you need to write it from scratch again.
Yeah.
Okay, that makes sense. All right. Yeah. Okay. This is actually an interesting game. I see how I can probably and again, because I am an integration architect, so the field of integration architecture is not exactly well uh, described in literature and practices, right? Low level, in code level, yeah, I can probably utilize exactly the same frameworks, methodologies as any other developer. But beyond that, there are no tools for specifically for integration architecture and integration development in terms of how to deal with these complexities, etc.
Right.
So what I always do when I read books about just normal programming, and I extrapolate the methods and adapt them to integration architecture, integration development, and I think this here actually wouldn't really need an adaptation to actually work for explaining the same principles in integration development. It would actually work amazing. They only but basically then conveying this to aspects of design, especially in the green parts. So how well do we actually understand what are we about to build?
Right.
Why are we building this, etc. And then actually those translating that to those M units or other relevant tests or integration tests, etc. Probably for integration specific, if I would make a game like this one, like yours, to explain this, probably would have to involve even more test cycles, test levels, because we get dragged into completely different aspects of testing and supporting that testing.
Right.
Because quite often we do the tests on the level of code with unit tests, but other tests which are really validating the functionality of integration are usually not done by us as developers, because they require literally other domain systems to work in a test environment to be able to conduct those tests, or testers building entire test suites in like SoapUI, Postman, or other tool to actually test that functionality and imitate the domain system behavior on the edges.
Right.
So the complexity of it all is slightly bigger than in developing a domain system.
Yeah, and that's something that TDD is very much often perceived as just this micro, very very inner loop kind of thing. But actually, there is the outer loop that some people call behavior-driven development, but it really is test-driven development, just at a different layer of the system. Like this is my API acceptance test. Let me know when you're done. And so then there is this outer loop that happens, and I've thought about, like, is there an expansion to this that focuses on that? Like, you have to get, it's not just any commits, but now it's commits related to this thing, and so there are all sorts of things. But you're right, like this is very much at this lowest level. There is other stuff that happens in that context.
I think looking at this, you could probably extend the board by another triangle around it. That if you manage to land 5 commits, you move to the outside triangle, which is then you're going through back and forth through end-to-end testing cycles. And you're fixing bugs that were found in your code. So there's a tester found a bug in your code. Now you need to deal with it, refactor or whatever. And that would be probably the scope of the expansion, that you look actually at the broader picture of the whole thing.
Yeah, I actually had that idea as an expansion. And it would be the expansion would almost be bigger than the game. But it turns out there's actually a game called the Agile Fluency game. So James Schuren and some other folks put it together, and it actually works at that much higher level. And so it's really interesting because like there's this little aspect of the game that's where this TDD game fits, but there is the whole larger thing. Unfortunately, that game is sort of hard to get a hold of because I don't think they sell it anymore and so on. But it was interesting to see like you can basically grow it out until you get to this larger level. And my refactoring expansion basically would sort of key off of this area where now you have to do things to gain, like it's not just refactoring as a card, but now you gain certain other abilities. But I haven't worked on those expansions yet because I'm busy working on a different game for a different topic.
Right. All right. So, I mean, I'm definitely going to play it with some of my devs just to get them going in that kind of engineering mindset thinking. I think at my current client, I think this could really get a great use to do so. So for those still with us, and I know that there are still some people watching, then there's a QR code. If you want to go and grab the game, I think the QR code actually leads to the physical version of the game that you can buy boxed up and shipped by TED to wherever you want. But there's also the printout version, which is a lot cheaper.
So there is on that page actually a link to the print and play, which is basically a downloadable. You get to print it and assemble it yourself. But if you are going to be at a conference where I'm going to be, I am happy to bring it to you and personally. So I'm going to be at Socrates, Germany coming up. I'm going to be giving some meetup talks. So I can give you the link to my calendar, which actually shows you where I am.
Nice.
And where should I put that link? Put it over here. So my travel, because I'm doing so much travel to Europe, I basically created an app to manage that. And so every time because I'll be in Europe for Socrates, Germany, and then for another conference called Play for Agile, which is also in Germany. So if you're in Germany, I'll probably be near you, and you can save on the shipping. Or you can if you've got a printer, especially if it's a nice color printer, and you've got good ways of cutting cards up and sleeving them, and you enjoy doing that kind of work, because it's, as I said, it's actually 90 cards plus another 18 cards plus the hex tiles. It's great for mindless work to cut those up. That's an option as well.
It's fun. I mean, I do have some balsa wood in the garage I could probably use to make the tiles, and then some really good sticker paper, so I can actually print the cards on the sticker paper, and then just have some sticker paper to cut into the right shapes to do so. So yep. I already have the printout version, so I'm just going to have some fun doing that. Yep. For the sake of it. Yep. But yeah, so for those watching, just go to the calendar, figure out where TED is. Maybe you can actually cross paths at a conference or a meetup, yep. And then you can get the game directly from TED and have a lovely chat.
And get it in a nice box.
In a nice box, exactly. Otherwise, if you just want it shipped, again, QR code, that's always an option. And before we part our ways, a few announcements. So, in less than a week, for a change, we're having a discussion about language, and we already touched upon language this stream. That language is a bit of a barrier that we need to always cross and figure out. So yeah, we're talking about the differences in language between data architecture and integration architecture. And returning to the stream is Andrew Jones. And we're going to be having some real fun there, because last time we talked to Andrew, and that was also with Rachel Barton, well, we really had some troubles because my jargon was completely different than theirs, They're in the world of data architecture. I'm in the world of integration architecture. We had so many misconceptions. It was fun. And of course, as by the end of the stream, upcoming events, you want to see all the events that we're going to be at least those that are already planned in the calendar. Then QR code to the left. We're still doing strategic integration design with TDD. This time around, the course is live at Avans Coperta. So scan it if you want to learn about integration architecture from me and Philip. And of course, if you're new to the channel, of course, it's always nice if you subscribe. That's always fun to watch the numbers grow. Not mandatory, though. So, that said, let me just kill the screen share. There we go. That said, Ted, any parting words for the audience in terms of learning TDD, trying TDD, figuring out TDD?
I think, like most things, it's like just try it out. Just don't just see what it's like. And if you ever have any questions about am I doing it right? See if you can find someone who might know just a little bit. Always the idea of reading a chapter ahead. They might be just slightly ahead of you. And so if you can, or even if you're both at the same level, working with someone else to try and figure it out and try to follow the rules, even if they seem tedious or don't make sense. You won't get it immediately, right? So as we saw and as we've discussed, there's a lot of nuance. But I think it's worth at least thinking about, even if you don't do TDD, but maybe just write the test first. It doesn't have to be these mini tiny steps that TDD really is good at, but think about just writing the test first. See what happens.
Just figure out what is the result. Just predict your result of your code, and then try to figure out are you right or wrong, and
see if you can predict and see if you can predict and see if and even if you're not doing things that are necessarily easily testable, if you are manually testing something, do a prediction. I'm going to do this. I'm going to click on this button. I expect this to happen, and get into that mindset of sort of verbalizing what you think is going to happen, because you have it in your head. You kind of have a sense, but often verbalizing it out loud clarifies that. Just like we say, writing is a form of thinking, verbalizing and talking about it is somewhat similar. And so try that out. Yeah.
I mean, I know for myself that verbalizing things is definitely something that works to go through a topic. I mean, I own a rubber ducky. It's a very old one from my T-Mobile days back in Poland. But basically, I'm rubber ducking all the time.
Yeah.
It's exactly that verbalization of things, that looking at the prediction, looking at just explaining what's going on and what I wanted to do and what I predicted to do. That's basically that is rubber ducking.
Yeah.
If you do that, you're already a step closer probably to working on that in that prediction mindset.
Yep.
By the way, I love to use people as rubber ducks. That's even better at times. That's card trading.
Yeah, they give you a little bit of feedback of puzzled looks, or oh, okay, I get it, and that really can help.
Yeah, that's very true. All right. That said, Ted, thank you for showing the game. Thank you for explaining TDD. Now I actually grasp the concept of TDD. That it's not about testing. It's about this design thinking, engineering, consciously engineering what you're building.
Yes.
Really cool to experience it through playing a game. That actually helps a lot.
Yeah,
you put a lot of effort into it to make it something that supports learning. That's actually a great tool. So I'm happy that you built it, because now I can use it to explain certain concepts to people. Even if it's not going to be directly TDD, but the concepts that are baked into the game, they're universal concepts that don't have to do with testing per se, but just skipping that design part of it and understanding the problem domain. This already is showing in the game what are the risks. Are you going to be held back and not able to proceed? So from even that perspective, that game is great just to play it for the sake of that. So
awesome.
Awesome. I'm just gonna sit down on the weekend and just start cutting hexagons to do the tiles from balsam
Great.
wood. See how that goes. I'll send you a photo.
All
All
right,
right.
good.
So for those still watching, thank you for staying with us tonight, and I suppose till Tuesday.